Welcome back Year 10s to the second video in this series covering algebra skills for maths methods. We're going to be looking at the elimination method for solving simultaneous equations, and I claimed that it was a more efficient and more powerful method at the end of the last video. However, we're not always going to want to use the elimination method. We only really want to use this method when it's advantageous to add or subtract the two equations so that we can get rid of one of the variables. And I think that it's best to illustrate this with an example. So let's do that. At the start of the last video, I gave you these two equations for you to think about. And I'm actually going to demonstrate the elimination method here. So if I call this equation 1 and I call this equation 2, I can eliminate y by there's different ways to write this, but what I'm going to do is say I'm going to add equation 1 and equation 2. So what's going to happen is x plus x is going to give me 2x. Y plus negative y is going to give me 0. And 10 plus 3 is going to give me 13. Which means x equals 13 over 2, or 6.5. See how easy that was? By simply adding the two equations, I got rid of one of the variables y, and I got a solution for x. And now I could substitute x equals 6.5. It doesn't matter which equation I choose, I'll just choose equation 1. And what I'll have is 6.5 plus y equals 10. Y equals 10 minus 6.5, which gives me 3.5. And therefore, the solution is x equals 6.5 and y equals 3.5. And those are the fractions if you prefer those. So let's check. 6.5 plus 3.5, yep, gives me 10. And 6.5 minus 3.5 gives me 3. That's the elimination method. Now, I didn't have to eliminate y. So I'll just say we could also eliminate x by taking equation 1 minus equation 2, or equation 2 minus equation 1. That would also have been acceptable as well. You just need to be careful of the negative sign, and I'll demonstrate that in the next example. So here we go. So I've got two equations, 2x plus 3y equals 14, and 2x minus 12y equals 74. I'll call these equation 1 and equation 2. And what you should see is that the two x's are the same in both equations. So I can actually see that to get from 3y to negative 12y, I have changed by negative 15y. And so I want to get rid of the x, because it's not really telling me anything significant here yet. So what I can do is I can eliminate the x terms by taking 1 minus 2, or 2 minus 1. Now, because I've written the equations in a certain order, most of you will be used to taking the top minus the bottom. So Some teachers will actually write it like this. They will put a minus sign, they'll put a big bracket down here, and then they'll almost write those lines that look a bit like the equal sign, and you would sort of do long subtraction this way. So you can do that if you like. I'm not going to do that. I'll just demonstrate this term by term. So first the x's, 2x minus 2x gives me 0. 3y minus negative 12y gives me positive 15y. So note here, I had to subtract negative 12y because I am subtracting everything in equation 2, which means I am subtracting minus 12y. So just keep that in mind. Okay? And then 14 minus 74 equals negative 60. And now if I divide both sides by 15, I get y equals negative 4. And now I can substitute this value for y into either equation 1 or equation 2. It doesn't matter which equation I choose, I'll get the same answer. I'll just pick equation 1 because it's plus y, so it's a bit easier. So substitute y equals negative 4 into equation 1 to find x. So now I'm going to have 2x plus 3 times negative 4 equals 14. 2x minus 12 equals 14. 2x equals 26. And that tells me x equals 13. And so the solution is x equals 13, y equals negative 4. One other comment I'll make is we could also have done equation 2 minus equation 1. And if we did that, we would have gotten negative 15y equals 60, which leads us to the same solution, y equals negative 4. Okay? So often when you're doing the method of elimination, there's more than one way to solve the problem, just as there is with the substitution method. You could substitute one variable or the other. Here, you can eliminate one variable or the other. It's just that in this specific example, the choice was obvious because the two x's were in common to both equations, and so that gave us the hint that we wanted to eliminate x. All right, we'll do one more example and then we'll leave it there. So here's our last example. I'm going to call this equation 1 and I'm going to call this equation 2. Now one thing you should immediately notice after having looked at this for a few moments is that I can't just do equation 1 minus equation 2 or equation 1 plus equation 2 because none of the coefficients of x or y are the same. So it might look like we're out of luck, but there's a little bit of a trick. What we can do is we can multiply each equation by a certain number so that the coefficients are the same. So what I'm going to do is I'm going to eliminate y by first defining a new equation, which I will call equation 3, by doing equation 1 times 8. So I'm going to take everything in equation 1 and I'm going to multiply it by 8. You'll see where this is going in a moment. And it's just dawned on me that this is going to be a massive number, but that's okay. 360. And I'm going to take everything in equation 2 and multiply it by 5. And I'm going to call the result equation 4. So 7 times 5 gives me 35. 8 times 5 gives me 40. And 46 times 5 gives me 230. So hopefully you're seeing where this is going. After doing this, this sort of scaling multiplication step, I've now got a situation where I've got 40 and 40. And now I can eliminate the y variable by taking equation 3 plus equation 4. I'm going to add the two equations, and then the plus 40 and minus 40y will cancel out. And that's going to give me the following. 24 plus 35, these are going to be big numbers. It's going to give me 59x. And then 360 plus 230 gives me 590. I set this up so that the numbers would be nice. So now if I divide both sides by 59, I'll get x equals 10. And yes, I will need to substitute this. So now I'll substitute this into equation 1 to find y. And so wherever I see the number x, I'll replace it with 10. So 3 times 10 plus 5y equals 45. So 3 times 10 gives me 30. 45 minus 30 gives me 15. And therefore, y equals 3, dividing both sides by 5. And hence the solution is x equals 10, y equals 3. I want you to just pause for a moment and appreciate how short this calculation was in comparison to how complicated this question looks. If we didn't have the elimination method, we would have to rearrange one of these equations for x or y and substitute that into the other equation, and we would get fractions everywhere. And we can do that, and we want to be able to do that, but if we can avoid tedious algebra and use something efficient like the elimination method, then we want to do that. We want to make life as easy as possible in the world of mathematics rather than making it complicated. So I hope that I've convinced you that the elimination method is, in these specific circumstances, more efficient. And I hope that you will use it to great effect in your studies. See you in the next video.